An underwater earthquake opens a huge gap in the ocean floor. A large volume of water moves to fill the crack. At the same time, waves start to spread out from that point. They're just a foot high at first, but the closer they get to shore, the larger they become. When the waves reach shallow waters, they start to slow down. Their lower parts get to dry land first. This creates a vacuum effect that pulls the water away from the coast. The harbor and seafloor are visible now. And then, an enormous wall of water hits the shore. It wipes out everything in its path. Several minutes later, more waves usually arrive. Or it can be a landslide happening near a large body of water. Enormous amounts of forest, soil, and rock roll down into a lake or ocean, producing huge tsunami waves. Volcanic eruptions are responsible for 5% of the world's tsunamis. They can move great volumes of water and generate really big waves. Some tsunamis are caused by meteorites striking into our planet. If one of these red-hot space visitors strikes the ocean, the force of this collision displaces enough water to produce an extremely powerful tsunami. When a tsunami starts, its waves are usually just 1 foot high. That's what a small wave looks like. It comes up to the waist of the average person. Surfers call such rather big waves double overhead. The largest earthquake ever recorded happened near the coast of southern Chile. It triggered a tsunami that reached Hawaii, Japan, and the Philippines. The tsunami's largest wave was as tall as a 5-story building. The largest wave ever surfed was half as tall as the Arc de Triomphe in Paris. Garrett McNamara set this record in 2011 in Nazaré, Portugal. In 1995, scientists proved the existence of rogue waves, sudden unexpected swells. On that day, they saw an 84-foot wave. It was taller than the world's largest passenger plane Airbus A380. The giant was surrounded by smaller 20-foot waves. Tohoku tsunami waves in 2011 were generated by the strongest earthquake in Japan's recorded history. The highest wave was almost half as tall as the Brooklyn Bridge. Krakatoa's volcanic eruption in 1883 produced the loudest sound ever heard on the surface of the planet. The highest tsunami wave the eruption formed was as tall as the Statue of Liberty. April Fool's Day tsunami in 1946 was triggered by a powerful earthquake near Alaska. The tsunami's highest wave was a bit taller than the Colosseum in Rome. The Boxing Day tsunami started in the Indian Ocean in 2004. It was caused by a powerful undersea earthquake. Its tremors produced a series of tsunami waves. The largest of them almost reached the height of the Leaning Tower of Pisa. One of the most disastrous landslides hit Lodeland Valley in Norway in 1936. An enormous piece of rock, almost twice as large as the Eiffel Tower, broke loose and hurtled into Lofoten Lake. This caused an enormous tsunami wave. It was almost as tall as the Taj Mahal in India. 2017 Greenland megatsunami was triggered by a massive landslide at one of the fjords. The waves that flooded the shore reached the height of Big Ben. A powerful volcanic eruption caused a landslide from a 4,000-year-old lava dome. This set off Unzen volcano megatsunami. The largest wave was half as tall as the Space Needle in Seattle. Fogo megatsunami happened 73,000 years ago, when a part of the Fogo volcano collapsed into the sea. The megatsunami's largest wave was as tall as the Washington Monument. When the upper 1,500 feet of Mount St. Helens exploded, it caused a massive landslide. A part of this avalanche plunged down into Spirit Lake. This caused a wave that was more than half the height of the Eiffel Tower. The Vejont Dam megatsunami happened when a landslide dragged 9 billion cubic feet of forest, soil, and rock into the lake. A colossal wave overtopped the edge of the dam, taking out everything in its path. Its height was greater than that of the Golden Gate Bridge. A landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. The megatsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. A third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean. This created a tsunami the size of the second tallest building in the world, Shanghai Tower. Earthquakes are a common thing in Japan. These natural disasters can reach a magnitude 9, where 1 is a light push and 9 can destroy entire cities. This happens because Japan is located on the Pacific Ring of Fire. It's like this. The entire surface of our planet is broken up into about 12 large pieces of the Earth's crust, and they're all moving slowly. In those places where these pieces meet, earthquakes occur most often. Japan is just at the point where the Pacific Plate collides with the plate of the Philippine Sea. This collision happens underwater and creates huge waves, and it could be much worse than just an earthquake. To escape from the water disaster, people built huge walls along the entire northeast coast. Not every earthquake provokes a tsunami. Many tremors occur when the Earth's crust diverges in different directions and creates gaps. It can destroy houses, streets, and forests, but such an underwater earthquake can't cause a tsunami. Huge waves are formed only when seismic activity causes the crust to move vertically up or down. The water pressure shifts at the very bottom, which generates a release of energy. This energy pushes the water and creates a tsunami. By the same principle, you can start little waves when you throw a stone into the water, and such vertical earthquakes often occur off the coast of Japan. First, a wave forms. It's gaining speed and increasing in size. Its height can reach about 40 feet, almost as tall as a 5-story building. It's approaching the coast and accelerating to 500 miles per hour. This is about the cruising speed of a commercial airliner. Millions of gallons of water weighing thousands of tons are getting closer. And now the wave is reaching the shore and demolishing everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. A tsunami that was that strong covered the northeast coast of Japan in 2011. It changed the landscape of the beach and the seabed. These changes are the reason for another dangerous natural phenomenon: underwater vortices. Whirlpools draw in everything that is nearby. They used to build dams along the coastline to protect coastal villages, but the wave force easily destroyed these walls. That's why, after the disaster of 2011, they decided to create new large-scale protection in Japan. They spent more than $10 billion in several years on it. As a result, they created about 440 massive walls all along the coast. They combined these sections into one large dam, almost 250 miles long and 45 feet high. The construction is supposed to protect the coast against strong tsunamis. But still, the government has moved some coastal villages to higher terrain. They also ban building anything by the shore. Despite the protection it gives them, many locals aren't happy with the wall. It's a huge problem for the fishing industry. The wall blocks access to the ocean, so ships and boats can't dock at the shore. Some people are unhappy that their windows now face the concrete wall instead of the blue ocean. The money spent on the wall could have been spent on moving even more houses. Residents have concerns the wall only creates an illusion of security. A giant wave can crash into it at great speed and break it into pieces. And these concrete parts can cause even more destruction. Some scientists agree with this opinion. Most experts aren't sure the wall won't give 100% protection, but it can help delay the flood, giving people more time to evacuate. In such situations, every minute counts. It's impossible to predict the earthquake occurrence accurately. But when it starts, the sensors can calculate how much time it would take for the wave to arrive at the shore. For example, the last time a tsunami warning was given 5 minutes after the earthquake. Any big wave is moving at great speed and may be very close to the shore. It seems people almost don't have time to save themselves from a tsunami. Fortunately, the citizens of Japan are ready for this. They regularly take part in tsunami evacuation drills. They learn how to act correctly during a coming flood. They have a plan of action that can save their lives. All that, along with the wall, increases the chances of surviving a catastrophe. Not only tsunamis are formed around the shores of Japan, the power of water here often meets the power of fire. In 2010, a few hundred miles south of Tokyo, near the island of Iwo Jima, A heavy, low rumble came from the depth of the sea. Then a million bubbles moved to the surface. The water started heating up and boiling. Its temperature was so hot that you could poach eggs in it. The hot area grew to the size of a stadium. All this was accompanied by a huge amount of superheated steam filling all the air around. Then pieces of soil came out from the water. At this point, it was all over. The water cooled down, the ocean surface became calm again. On that day, an underwater volcano erupted. No catastrophe occurred, but in 2021, this happened again. Japan's Coast Guard warned of strong volcanic activity in the region. Hot steam and gases from the volcano's mouth burst out of the water and rose into the air to a height of 10 miles, which is about twice as high as the top of Mount Everest. A huge volcano woke up and began to rise slowly from the surface. If you look at this place from above, you can see that it's not just a volcano, it's a whole island shaped like a horseshoe. Seismologists say this volcanic island is just the tip of the iceberg, as they mix their metaphors. There is still a lot of volcanic space under the water. The island fills the air with gas and ash. The sky turns gray. Scientists continue to monitor the volcano, but they don't know what consequences this may lead to. Such eruptions of underwater volcanoes are not uncommon off the coast of Japan, but the event itself is unique. Underwater volcanoes don't explode and don't release lava flows upwards. A huge amount of water above them creates high pressure. As soon as the magma gets out, the water immediately presses it to the seabed. Millions of gallons of lava sink, cool down, and solidify around the volcano. This lava forms a thick layer of Earth's rock. Most underwater eruptions don't cause any changes on the ocean surface, but to make an island appear on the surface, a volcano needs a lot of magma. The next volcanic eruption creates another thick layer of it. Millions of years pass, and flows of lava form mountains. Constant eruptions increase the seabed height. Layer by layer, the cooled lava rises higher and higher, and then one day it appears on the surface and turns into an island. So, in 2013, a small piece of land appeared next to an existing island. Emerging from the water, the volcano began to grow slowly and eventually connected with the island. The area of this island increased by 12 times after 2 years. Vapor is always pouring out of this island, and its surface is filled with super hot lava flows. The volcano behaves unstable, and nobody knows when it's going to calm down. Once, people built a small town on a similar island. This place still exists today. It's located south of Tokyo and is called Aogashima. People are not too worried about the possibility of a catastrophe, despite the fact the last time a volcano erupted here was in May 1785. I wasn't around then. By that time, people had already built a city and lived there. Then, one sunny day, thousands of birds suddenly took off and left the island. Then the ground began to shake. A heavy, low sound came from the island depths. Streams of gas rushed from the top of the overgrown forest volcano. The volcano threw dirt and large stones into the sky. The eruption wasn't quick. It lasted several weeks. More than 200 years have passed since then, and the volcano is still sleeping. They rebuilt the city. Now this place looks like a dream. That's probably the reason why people don't want to leave it. Despite the risk of a new eruption, they continue to live and work here. There are many thermal springs. The island also has rich soil, and the waters around are full of fish. The volcano may wake up at any moment. Fortunately, meteorological and seismological services monitor the volcano activity. So, any guesses? So, the distance from New York to Lisbon, on the other side of the Atlantic, is well over 3,000 miles. At the average walking speed for a human, you could trek there in a month and a half. That's not counting the rest stops and much-needed sleep. Buying an airline ticket or boarding a ship aren't just better options, but the only travel possibilities right now. But if this long journey on foot became possible one day, would you be up for the challenge? The most obvious obstacle is all that water in the Atlantic Ocean. It covers around a fifth of the Earth's surface. All the oceans take up around 70% of our planet. When you open the tap or buy a bottle, you are drinking a tiny percentage of potable water. 97% of Earth's water is located in oceans. It's all salt water and it's not drinkable. Add this 2% of water trapped in glaciers and ice sheets, and you get less than 1% of water that we actually drink. When you put these percentages into numbers, you'll need a long sheet of paper to write them all down. The U.S. Geological Survey estimates that there are over 330 million cubic miles of water in the world. It's essential for sustaining all life forms, including humans. Oceans play a vital role in regulating air temperature around the globe. If they didn't have any water, the area around the equator would be scorched. This imaginary line that divides our planet in half runs through 13 countries in total, such as Brazil, Kenya, and Indonesia. The world's oceans are critical for our planet's water cycle. You know, like the one you learned about in school? It rains from the clouds and water eventually ends up in rivers that empty into the oceans. Then sunlight warms up this vast body of water, so it evaporates into the atmosphere to form new clouds. Then the cycle starts over. This process shapes the global climate. That's why, for example, the Mediterranean is so popular for the summer holidays. The region is temperate. If we take the oceans out of the equation, the water cycle stops. The area where they once sat would turn into a huge dust bowl. There would be dirt as far as the eye could see. Since there is no more evaporation, clouds won't form. Rain would become scarce. Humans would soon run out of sources of drinking water. The landscape of our planet would turn into a vast desert. Imagine a Sahara-like terrain stretching across the surface of our planet. Everything would become so dry that fires would break out easily. These are hardly the ideal conditions for a long trek between continents. But let's imagine you were able to survive all this. You start walking across the desert land that was once the Atlantic Ocean. What would that journey be like? You would encounter a landscape different from the one above the waterline. Everything below the waves is taller and deeper than the world we know. This is the land of extremes. Take, for example, the highest mountain on the planet. If you were thinking about the Himalayas and its tallest peak, Mount Everest, you are correct. Well, kind of. This mountain range is the highest when you measure it from the sea level, just above 29,000 feet in height. But when you measure the height of the mountain from its base to the peak, then the Himalayas drop to second place. The highest mountain on Earth is actually Mauna Kea in Hawaii. It's a dormant volcano. In the local language, its name translates as White Mountain. Nearly half of it lies under the waves of the Pacific Ocean. Its full height is close to a mile higher than Mount Everest, at 33,500 feet. We can't appreciate its scale right now, but if the Pacific dried up, we would be able to stand at the base of this giant. The bottom of the Atlantic hides a similar mountain range. It's the largest geological feature on the planet. We can't see it because the mid-Atlantic ridge is almost completely submerged. It rises from the ocean floor to a height half of that of Mount Kilimanjaro. The width of the massive underwater range reaches 1/10 of Earth's diameter. The only visible sections of the mid-Atlantic ridge are islands such as Iceland and the Azores. The remotest inhabited island in the world also belongs to the visible part of this geoformation. Perhaps the only thing more impressive than its size is the date of the discovery of its ridge. Scientists charted it out in the 1950s. That's pretty recent when you consider our civilization is thousands of years old. This shows how little we know about what's hiding under the surface of our oceans. UNESCO estimates that humans have explored only 5% of Earth's oceans. It seems hard to believe, but more people have been to the moon than at the bottom of the ocean. The deepest place on our planet lies in the Mariana Trench. The discovery of the Mid-Atlantic Ridge revealed the secret behind the formation of continents and oceans. When you know the truth behind their origins, you'll know what to expect on your imaginary trek across the Atlantic. The ridge sits right between North America and Europe. But you need to think of these landmasses not as continents, but as tectonic plates. These are huge chunks of Earth's outer layer. It's called a lithosphere, and is mostly comprised of rock. There are around 15 to 20 such ginormous plates on our planet. They float on a layer of partially molten rock. Well, they don't actually float, but that's the term scientists use to best describe their instability. Tectonic plates are constantly on the move. They can bump into each other. In this case, one plate goes down while the other one is lifted. This creates vast amounts of energy. On the surface, we get earthquakes and volcanoes. Tectonic forces gave our planet its familiar shape. That's how the Himalayas formed 40 to 50 million years ago. Around that time, the Indian plate shifted northward. It bumped into the southern part of the Eurasian plate. Since the two plates were composed of a similar type of rock, they each refused to go under the other. The only possible direction was up. This process is still not over. The range grows by 1/3 of an inch every year. A similar thing is happening with the Mid-Atlantic Ridge. It is widening at an annual rate of 1.5 inches. And there's an interesting side effect of this process. Do you remember the time when you were building sandcastles? In order to build the keep, you needed to dig up a lot of sand around it. As the castle grew in size, the hole around it became bigger. The same thing is happening in the Atlantic Ocean, but on a much larger scale. As the ridge is getting wider and wider, the two coasts are drifting away from each other. The North American plate and the Eurasian plate are moving apart. This means that your imaginary trip in a world without oceans might take longer. For every year you wait, you'll need to cover an extra inch. Now, that doesn't seem like much today, but give it some time, and you might not have to embark on a cross-continental journey after all. The continents will come to you. Now, evaporation is not the only way to drain an ocean. The coast on each side of an ocean might simply close in on it. This is what scientists believe will happen to the Pacific. Some 50 million years from now, give or take, you wouldn't be able to recognize the Earth's largest ocean. Experts ran a series of computer simulations to see where North and South America are headed. The answer is to the North Pole. This is where they'll merge with Asia in the distant future. The new supercontinent will completely change the shape and size of the Pacific Ocean. Geologists have a name ready for this landmass: Pangea. The ground shakes beneath you. The pictures rattle on the walls. You hear a rumble off in the distance. Then, boom, a deafening explosion. The shockwave blasts through the windows and sets off car alarms. You duck under the dining table for cover, but then you remember you live not far from a supervolcano in the middle of a tropical jungle. So, staying in one place isn't a good idea. The shaking finally halts. You take this chance to peek outside and see a giant cloud of smoke covering the sky. It's lunchtime, but you wouldn't know it. The sun is completely veiled and darkness falls. The power's out in the whole city. In this darkness, you see red molten lava shooting from the sky and spilling on the rim. You run outside along with dozens of your neighbors. Your priority right now: find safe shelter and fast. You think about taking the car, but with everyone running on the road, that's a no-go. So you run on foot where the crowd is going. Supervolcanoes are in a league of their own when it comes to natural disasters. Surprisingly, it's not all about size or height. A volcano is dubbed super if it erupts more than 240 cubic miles of magma. That's more than enough to overfill Lake Erie. It must also have a history of erupting and a magnitude of 8 on the Volcanic Explosivity Index. The largest active volcano on Earth is Hawaii's Mauna Loa. It's so big, it would cover the entire state of Rhode Island plus some. And next time you see a commercial plane flying high in the sky, remember that 30,000-some foot altitude is about as tall as Mauna Loa is from base to summit. It's technically taller than Everest when you measure it like that, yet it's not considered a supervolcano. So you're running along the dark road not knowing and barely seeing where to go. Then, all of a sudden, a massive flaming boulder smashes through the bridge in front of you. You and everyone else are now stranded on the side of the volcano, as it's getting more chaotic each second. Most of the crowd disperses, finding their own ways to safety. You remember there's a way to the other side not many people know about, but you'll have to cross a raging river through the dense jungle. You calm what's left of the crowd, and everyone follows you to your secret getaway. You finally get out of the city limits and head into the jungle. With the sky already dark, the tall trees and thick leaves make it almost pitch black. Everyone gets out their phone flashlights to navigate through the dark path. You all need to stick together and make sure nobody gets lost. Suddenly, fiery rocks strike the trees not far from you. Everyone jolts and tries to rush ahead, but nowhere is safe when it's raining scalding fire all around. You and your group have to pick up the pace or else. Imagine a typical avalanche or mudslide, very dangerous situations on their own. Now, imagine an avalanche of lava rocks and lava sliding down a mountain instead of mud. That's what's making its way towards you right now. More and more people catch up with your group and bring news that the entire neighborhood is submerged in lava. It's traveling quicker than you thought. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can move slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous problem. If you didn't have protection, the gases spewing from the eruption would fill your lungs, and those spread faster and further than the lava flow. Your eyes and throat would be itchy. You'd get a headache, dizziness, increased heart rate, difficulty breathing. The worst would be passing out from the lack of oxygen. Luckily, everyone managed to grab their gas masks before leaving their homes. You're now entering the treacherous terrain of the jungle and the danger zone. Everyone's phone batteries are giving out one by one, so your vision is even more limited. The terrain is tougher and you can't hear any sounds from the river. At this point, you're not even sure if you're going the right way. But your instincts tell you the deeper you go, the safer you'll be. The path is muddy, and the vines are hindering everyone's movements. That's when you hear something big running through the jungle. It's coming up on you fast. You can't see a thing until it's right up on you. A bear! And there goes a rhino. Wild cats, domestic cats, dogs, different creatures of all sizes and species. They all come running through the jungle right past you. You and your fellow humans aren't the only ones fleeing from the eruption. The rumbling is still going on. Before you know it, a shower of fire rocks strikes right behind you and ignites parts of the jungle. There's no going back. Everyone picks up and runs for it. You hear thunder in the distance. A flash of lightning lights up the dark sky. You think, finally, some rain to wash away this fiery nightmare. But that's not a regular storm brewing. These giant smoke clouds can mimic a thunderstorm under similar conditions. Your luck finally pays off. You hear the river straight ahead. You reach the bank and have to hop on some stones to get to the other side. You almost slip when someone from the group catches you just in time. Whew, that was too close. Not far down the river is a large waterfall leading straight to a shallow lake with sharp rocks at the bottom. The ash from the lava falls like snow, covering most of the trees and landing on the river. Ash is one of the most dangerous things about volcanic eruptions. You're soaked to the bone, but it's a lot better than ash and smoke. And then the rest of the group follow. The next thing you know, the river starts steaming as lava meets the bank and runs into the water. You try your best to speed things up. The lava can heat this water up to dangerous levels, and there are still people slowly crossing the river on the slippery rocks. Luckily, you manage to get everyone across. Well, almost everyone. You turn around and see someone's leg got caught between two rocks. The lava continues to pour into the river. You can feel the heat of the steam. You rush back to this person and try to pull them out. Their leg won't budge. Someone else from the group comes to help, and you're finally able to pull them out in the nick of time. You and everyone else, now exhausted from your trek, keep going as far as possible. That's when you see the main road that connects you to the broken bridge. There are others on the road that got out safely, and even some cars filling up with survivors and heading fast out of the area. The volcano is still spewing lava, and the entire city is flooded with it. What was once your town now looks like a giant burning lake. Planes and helicopters can't fly because of the smoke and ash, so don't count on an air rescue. You're still at risk even though you're on safer ground, so it's still too early to celebrate. Everyone continues to move away from the city. The further, the better. The ground continues to shake, but this time it's even more intense than before. Supervolcanoes are powerful enough to cause many earthquakes. But it's a good thing you're out in the open, far from the buildings and debris in the city. Now, back to reality. Rest assured that a volcanic eruption of this intensity won't happen for a very long time, as in millions of years. Besides, thanks to warning systems and humanity's preparation for such an event, it's extremely rare for even a regular volcano to do as much damage as it could. So, don't scratch Yellowstone off your travel list just yet. Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangea. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question, if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system. Now at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other: the Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lunch, lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So, people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat.
Fraser Island sits off the coast of sunny Queensland, Australia. But don't fall for its beauty. It's home to the most dangerous beach in the world. There's nowhere on the island to seek medical attention. If you do run into danger, you're on your own. Dingo attacks are super common here. If you don't know what a dingo is, it looks like an adorable dog. But beware, this wild breed is extremely dangerous. And the dingo's gnashing teeth aren't the only thing to be scared of. The seas around the island are swimming with great white sharks. There's jellyfish in the water too. Fraser Island is home to some of the world's most dangerous kinds, including the Portuguese bluebottle. One sting from its venomous tentacle is enough to take down an adult human. Even if you manage to avoid the creatures on the island, the sea itself is perilous. The waters are incredibly rough and have powerful riptides. These are strong currents that will pull you away from the shore. And remember, there are no lifeguards to come to your rescue if you get in trouble. Even the sand is dangerous. Car rollovers in the thick dunes happen all the time. It's definitely best to swap your car for a dune buggy. Travelers also often drive down the dunes straight into the lakes below, but the lakes are incredibly shallow, which is not very safe. Fraser Island is also known for its beautiful lookout points, but you'll need to watch your step. You might feel on top of the world, but stay well away from the edges as jagged rocks and crashing waves line the shore below. There's an island in Brazil known as Snake Island, which is equally dangerous. I wonder what the hazard could be here. It's home to thousands of golden lancehead vipers, which are one of the most venomous snakes on the planet. They grow to over 20 inches long, and their fast-acting venom melts the flesh from around their bites. There are around 4,000 snakes on the tiny 106-acre isle. Snake Island has become so dangerous that the Brazilian authorities had to ban everyone from going there. For years, the only human inhabitants to brave the island were a lighthouse keeper and his family. But local legend says that one night a group of snakes crawled in through a window to attack, and the family was never seen again. Known as the gas mask town, the island of Miyakijima is not one to visit in a hurry. It's home to a fiery, active volcano that has erupted several times over the past few years. There were several massive eruptions leading to the spread of a highly poisonous gas across the island. Residents are now required to carry gas masks at all times, and a terrifying alarm blares across the island whenever the poison levels get too high. The island is also in the middle of the Devil's Sea. Ships mysteriously vanish in the area, and experts have no idea why. The North Sentinel Island is home to a remote and unwelcoming tribe. They lived alone on the island without any modern technology or contact with the outside world for over 60,000 years. And that's just the way they like it. They've been known to fire arrows at anyone who attempts to enter the island. There are many stories of people visiting the island, and they are never seen again. It's not ghoulish ghosts or slithering snakes that you have to worry about on the Caribbean island of Saba. It's hurricanes. The tiny island has been hit by more severe hurricanes than anywhere in the world over the last 150 years. There have even been 7 tropical cyclones, which is an intense circular storm. The winds in these storms can reach 254 kilometers an hour. Try standing up in that. You'll also struggle to find a pilot who'll even land on the island. It's incredibly dangerous not because of the winds, but because it's home to the shortest runway in the world. It's only 440 yards long. 2 huge rocky ridges surround the runway, so there's no room for mistakes. The Kilauea beaches of Hawaii used to be one of the most dangerous in the world. The Kilauea volcano has been almost consistently erupting for the past 35 years, spewing red-hot lava into the surrounding waters. The water temperatures have even passed boiling point as a result of the lava. Happily, it's no longer active. While the island of Bikini Atoll might sound like the perfect summer vacation destination, it's most certainly not. The problem is that this place has dangerously high radiation levels, and the locals had to leave it. Although the island was declared safe in the 90s, its original inhabitants have refused to return. The lack of fishing in the area has also led to a massive increase in sharks who swim the waters in search of their next meal. Strangely, the corals and reefs are thriving. From the distance, Ramree Island looks idyllic. White sand, swaying palms. But beware. They say thousands of hungry saltwater crocodiles used to lurk there, ready to strike at any time. The exact number of those animals was unknown, and some scientists claim that there are quite a few of them right now. I'd stay well clear of the island though. I don't really feel like becoming crocodile food. Skeleton Coast in Namibia is appropriately named as the harsh landscape and lack of water make life almost impossible. Whale carcasses, turtle shells, and elephant rib cages litter the shore. If that isn't bad enough, lions and hyenas patrol the beach in search of their next meal. The surrounding waters are just as dangerous, as they are home to 11 different species of shark. Many sailors have become lost on this coast and have never been seen again. Cape Tribulation in Australia also lives up to its name as it is packed full of dangers. Swimmers have to wear special stinger suits because the water is teeming with stinging jellyfish. Saltwater crocodiles also hide in the water, but they don't make a suit to keep you safe from those. It's not just the jellyfish that sting. The area is covered in stinging trees. The trees have jagged leaves that give the crocs' teeth a run for their money. On land, there's angry cassowary birds. There are flightless birds that are the same size as an ostrich. They have sharp talons that can easily slice through skin. The Utterkleiv beach in Norway is one of the best places to see the northern lights, but you'll be lucky if you survive more than one night there. The seas surrounding the island can reach 46 degrees Fahrenheit, and that's just in the summer. It probably feels like swimming in ice cream. For years, Gansby Beach has remained a habitat for the most dangerous creatures on the planet. Sharks are particular fans of its waters, and the coastal stretch is known as the Great White Shark Capital. The sharks are attracted to the 60,000 sea lions that flock to the beach every year. Not just shark food, wild sea lions can be unpredictable and aggressive towards humans. Comoro Islands are the worst vacation destination for those who don't really like mosquitoes. The place is swarming with the little guys. Locals say all the water on the island must be contaminated because of them. So they like to sterilize water before drinking, making ice, and even brushing their teeth. If you're really into coconuts, there's one place you should probably go to grab some. I'm talking Danger Island. Yep, it's the real name of one of the islands in the Chagos archipelago. It shouldn't scare you off though. The major problem it has is parking. I mean, safe anchorage for those who come there. Finally, while it may sound dreamy, you're probably going to want to avoid the beaches of the Amazon. Sharp-toothed red-bellied piranhas, anacondas, and electric eels are just some of the beach's regular residents. It has one of the widest varieties of animal species on the planet, including the Amazonian giant centipede, which has a poisonous bite. It's not just the animals of the Amazon that you have to watch out for. Strychnos and curare are the two Amazonian plants that are super poisonous.
Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia. Hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylacoleo. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritius broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zirkons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future.
The largest volcanic region on Earth is not in Africa or Japan, but under the ice of Antarctica. Scientists found 138 volcanoes in its western part, and if they decide to go wild, you'll surely notice it. They could melt huge amounts of ice that will move into the ocean, raise its level, and make our planet uninhabitable for humans. But before you pack your things to fly away to another planet, hear me out. Only 2 of the Antarctic volcanoes are officially classified as active now. And it would take a whole series of eruptions, decade after decade, to seriously impact the whole world. Mount Erebus, one of the 2 Antarctic volcanoes currently in action, proudly bears the title of the world's southernmost active one. It has been continuously erupting since at least 1972. It emits plumes of gas and steam and sometimes even spews out rocks, and scientists call it Strombolian eruptions. One of the coolest features is a lava lake in one of its summit craters, with molten material on the surface. Such lakes are rather rare because they need certain conditions to make sure the surface never freezes over. The second active volcano is Deception Island, a horseshoe-shaped landmass. It is the caldera of an active volcano that last erupted over 50 years ago. Scientists who monitor it say it shouldn't go wild anytime soon. Antarctica also has plenty of fumaroles. Those are volcanic vents that release gases and vapors into the air. In the right conditions, they can spew out enough stuff to build fumarolic ice towers up to 10 feet tall. Scientists keep an eye on the Antarctic volcanoes with seismometers that detect when the Earth starts trembling from volcanic activity. Sometimes they also use more complicated tech, but it's all really challenging because of how far away this polar region is and how tricky it is to get there. That's why no one can predict when one of the continent's volcanoes that are now sleeping might erupt. We can guess what this waking up would look like if we analyze the events from nearly 20,000 years ago. So, shall we? One of Antarctica's sleeping volcanoes, Mount Tecate, had a series of eruptions and spewed out a good amount of halogens rich in ozone back then. Some scientists say these events warmed up the southern hemisphere. glaciers started to melt and help finish the last ice age. For these events to repeat, we'd need a series of eruptions with substances rich in halogens from one or more volcanoes that are now above the ice. It's an unlikely scenario, but since it already happened in the past, it's not completely impossible. As for volcanoes hiding under a thick layer of ice, it looks like their gases would hardly make it to the atmosphere, but they would be strong enough to melt huge caverns in the base of the ice and produce a serious amount of meltwater. The West Antarctic ice sheet is wet and not frozen to its bed, so this meltwater would work as a lubricant and set the overlying ice into motion soon. The volume of water that even a large volcano would generate in this way is nothing compared to the volume of ice beneath it. So a single eruption wouldn't make a difference. But several volcanoes erupting close to or beneath any of the western Antarctica's big ice streams would. Those ice streams are rivers of ice that take most of the frozen water in Antarctica into the ocean. If they change their speed, then bring unusual amounts of water into the ocean, its level will rise. As the ice would get thinner and thinner, there would be more and more new eruptions. Scientists call it a runaway effect. Something like that happened in Iceland. The number of volcanic eruptions went up when glaciers started to recede at the end of the last ice age. So it looks like, for massive changes, several powerful volcanoes above the ice with gases full of halogens need to get active within a few decades of each other and stay strong over many tens to hundreds of years. Antarctica stores around 80% of all the fresh water in the world, and if they melted all of it, global sea levels would rise by almost 200 feet. And then we'd have to look for a new planet to live on. But this again is an unlikely scenario. It's more likely that the eruptions under the ice will lubricate ice streams and seep water into the ocean. But it wouldn't be the end of the world. A super strong, super angry supervolcano could do it though, and it has already happened in the past. Over 200 million years ago, the world went through a major makeover with not one, not two, but 4 massive volcanic eruptions in huge pulses. The supervolcano called Camp had been erupting over and over for 600,000 years. It all happened in Rangelia, a large chunk of land that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. And it wasn't the lava or the volcanic ash that ruined the environment. The eruption made carbon levels skyrocket. The planet would never be the same again. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in Asia to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels. It made the atmosphere toasty, and the rain poured down. So the bad news is, another eruption like this could happen. The supervolcano beneath Yellowstone National Park has been sleeping for nearly 70,000 years. But if it wakes up, it would be many times more catastrophic than the eruption of Mount St. Helens in 1980. It's considered the most disastrous volcanic eruption in U.S. history. It followed 2 months of earthquakes and injection of magma below the volcano that weakened and destroyed the entire north face of the mountain. The eruption column went 80,000 feet into the atmosphere and spread ash over 11 U.S. states and several Canadian provinces. The last Yellowstone eruption was 1,000 times greater than that. The ground above Yellowstone sits on a hot spot made of molten and semi-molten rock called magma. This magma stuff flows into a chamber beneath the park, about 4 to 6 miles down, making the ground puff up like a balloon. But then, as it cools down, the ground goes back to its usual state. Volcano watchers have been keeping an eye on this for a century. They noticed the ground lift up about 10 inches around 20 years ago, but since 2010, it's been going back down. The experts say we have no big eruptions on the horizon, so doomsday isn't coming anytime soon. But there's some underground activity going on lately which keeps us interested. Since humans haven't been around to witness every little thing Yellowstone does, It's kind of tough to say for sure what's brewing down there. Yellowstone has had some epic eruptions within the last couple million years. They happen like clockwork, with gaps of 600,000 to 800,000 years between them. The last big one was around 640,000 years ago, and it basically reshaped the entire landscape, spreading ash and debris as far as Louisiana. You can still see the aftermath of the last big eruption in the Yellowstone caldera today. Experts say a massive eruption like the last one is an unlikely scenario. We're more likely to see eruptions of steam and hot water or lava flows. When and with what force it will wake up remains a mystery to scientists. I'll bet you've heard of the lost civilization of Atlantis sinking into the waters off the coast of ancient Greece. The story is supposed to be a myth, but have scientists finally found the lost city? Not sure about that, but they did find a lost continent. Wait just 1 minute, I've lost socks, keys, and even a few marbles. But how careless do you have to be to misplace an entire continent? We'll have to ask our planet about that one. Earth lost what was called Greater Adria between 100 and 120 million years ago. So, how did that happen, and where did it go? The only way to describe the process would be kind of like a snake slipping through rocks or going down into a hole. It's easier to imagine losing a continent when you think about how hard it is to find a snake that's escaped your curious stares. Most snakes don't leave trails. In fact, if you weren't around 100 million years ago to watch that snake slide beneath a boulder, and I wasn't, you'd never know it happened. Just like scientists might never have found Adria if it weren't for the snakeskin, the mountains. Let's say your fleeing snake slithers under a rock. It's long past due for a shedding, so its old skin scrapes off and bunches up right there in that tiny space between the boulder and the ground. That's what Greater Adria did. When it broke off from a humongous landmass known as Gondwana, stick around for more on that here in a few, the Greenland-sized chunk headed north. When it eventually crashed into Europe, it slipped under and caused the meeting place of the two continents to fold and scrunch up. For years and years, it just kept going, and those folds kept growing. In the end, it left behind very obvious and famous traces. You might even have gone skiing on them during a winter vacation. I'm talking about the Apennines and the Swiss Alps. Professor Douwe van Hinsbergen, the geologist who led the research team responsible for this colossal discovery in September 2019, has his own analogy. He compares this folding action to what happens when you stick your arm into a small space and your shirt sleeve can't fit through. It bunches up, and those bunches are like the mountain range. You might be wondering if other mountain ranges have similar origins. They do. Ever push sand together with your hands? Your hands work like shifting land masses, and those peaks of sand you created are a mini version of the Rockies. The snakeskin, your shirt sleeve, the sand. The point here is that mountains get left behind when massive chunks of land smash into and slip under each other. But what about the disappearing continent that leaves them? What happened to Greater Adria itself? Just as a snake burrows underground for the winter, Adria kept sliding beneath the surface. Dr. van Hinsbergen thinks she's probably nice and cozy about 900 miles under southern Europe right now. But wait a minute, is Greater Adria still a continent if she's underwater or under land? Is a snake still a snake when it's underground? Of course it is. In fact, I know a continent that's mostly underwater yet isn't lost at all. Ever heard of Zealandia? It's also called the New Zealand continent or Tasmantis. It looks like an archipelago, which is a string of islands. But if you peek under the water, you'll see that it's really one continuous piece of submerged land with mountaintops poking out over the surface. Those peaks are the islands. Zealandia is categorized as a microcontinent, which then begs the question: what is a continent anyway? That's a matter of some debate. In fact, we Earthlings can't even agree on how many continents, not counting the lost and micro ones there are. Generally, a continent is an enormous landmass. If you're from the US, you heard that there are 7 of them: Africa, Antarctica, Asia, Australia, also called Oceania, Europe, North America, and South America. European school kids, however, combine Europe and Asia into Eurasia, so they only learn 6 continents. South Americans also recognize 6, but they keep Europe and Asia separate and combine North and South America instead. What's even stranger is that everyone seems to agree that Australia is a continent, while Greenland isn't, and has to make do with the title of World's Biggest Island. Poor Greenland. This all has something to do with the tectonic plates that lie beneath the continents, but that's a discussion best left for another video. So, where did all these continents come from in the first place? Well, if you've ever looked at a globe or a map, you probably noticed that the 2 great landmasses surrounding the Atlantic Ocean, North and South America on one side and Europe and Africa on the other, seem like puzzle pieces that could be pushed together to form one even more gigantic mass. You might also know that there's a name for that mass – Pangea. Scientists think Pangea, a supercontinent if there ever was one, broke apart 175 million years ago, but not into those 2 big left and right puzzle pieces we have today. Instead, the split probably ran horizontally, leaving a connected North America, Europe, and Asia on top, a mass called Laurasia, while South America stuck it out with Africa, Antarctica, and Australia in a mass known as Gondwana. Yes, that very one that Greater Adria would break free from later on. So, if you took all of Earth's land masses, continents, microcontinents, islands, and archipelagos, and squished them together, would you get the original blob of land known as Pangea? Nope. Not only would you be missing the parts of continents that lie underwater, like the masses connecting archipelagos, you'd also be missing all the ones lost over time. Oh yeah, there are others besides Adria. Scientists are looking for them, and they've already found some. One of those lost continents is the Rio Grande Rise. It's a stretch of underwater seamounts that's been dubbed Brazil's Atlantis. Greater Adria lay somewhere between North Africa and southern Eurasia. Hey, that's right around the Mediterranean Sea, and the Mediterranean is where Greece and Athens are. So, Greater Adria must have been Atlantis, right? Doubtful. Historians think Plato made up the story of Atlantis, but could it have really happened? You might think so if you believe the story of Greek deities punishing the civilization for starting a beef with Athens. But a more scientific theory would propose that Atlantis was simply flooded. Or perhaps it could have been one of the islands scraped off and left behind when Greater Adria dove under Europe. Disappointing as it is to say, the one thing we can't be sure of is that Adria itself wasn't Atlantis. The tectonic forces that shoved the continent under Europe did so over 100 million years ago. That's about 80 million years before any human showed up on our planet to start a conflict with Athens or anyone else. If you look at all the world's continents like broken puzzle pieces that formed a shattered Pangea, you could say that Dr. Van Hinsbergen and his team have spent the last 10 years trying to put that puzzle back together. And like actual puzzles, it's hard to do that when you're missing a bunch of pieces. I'm looking at you, Adria. But they have fancy geological equipment that tracks the magnetic record left behind in the rock's minerals. You see, every rock, stone, and mountain has a sort of imprint of the time and place it was created. It all has to do with the Earth's magnetic poles. They change every now and then in a process called geomagnetic reversal. So, in a nutshell, the specific magnetism of certain sediment and minerals works like a map and calendar. And that's how they know where Adria came from, where she ended up, and who she met along the way. By studying the magnetism of these samples, the team also found out another interesting detail. Greater Adria not only crashed into Europe, but she was also spinning on the way there. A twirling, dancing mass of land whose carefree trip northward would be cut short by an unexpected roadblock known as Europe. Hey, that would make for a great bedtime fairy tale for the kids. Now, my only remaining question is, if Greater Adria dove beneath Europe, could she rise again? It is possible. Continents keep shifting, and they remain on the move today. But they tend to go at a snail's pace, So check back in another 100 million years and we'll see how many continents second graders are learning about in the future. I won't be here though. I'll probably retire. So, you notice anything weird? Recently, there have been alarming changes in the water levels in different parts of Yellowstone Lake. At the same moment, the water level can be rising on one side of the lake and falling on the other. Ooh, it looks as if the lake basin gets lifted by some underground forces. Can it be a sign of a looming disaster? Geysers, mud ponds, and hot springs turn Yellowstone National Park into some extraterrestrial world. And all these wonders are fueled by a mighty supervolcano. Supervolcanoes produce super eruptions. When it happens, they launch more than 240 cubic miles of ash, molten rock, and hot gases up into the air. To make it easier to imagine, 4 super eruptions could fill the Grand Canyon to the brim. The Yellowstone giant was thought to be responsible for at least 3 enormous eruptions and countless smaller ones. In that region, the volcanic deposits are scattered over tens of thousands of miles. Scientists believe they had been created by many weak eruptions. But after doing more research, experts found out these deposits had been left by 2 previously unknown super eruptions. Those probably took place about 9 and 8.7 million years ago. This discovery means that the area around the Yellowstone volcano used to face a super eruption every 500,000 years. But over the last 3 million years, the hotspot has seen only 2 super eruptions. It makes scientists believe these catastrophic events are slowing down, or just maybe one is overdue. Anyway, if the Yellowstone supervolcano went off with as much power as it had 2.1 million years ago, it would spit out more than 588 cubic miles of boiling lava. That's more than 4,500 times the volume of Sydney Harbor. That's a lot of lava. Whether it's likely to happen or not is another question. There's no doubt that something is going on with the volcano. The water level changes in Yellowstone Lake mean the caldera is lifting under the surface. And the caldera is what's left over after a volcano erupts and then collapses. The Yellowstone caldera is not just going up, creating a dome-shaped uplift. It also moves up and down in a kind of breathing motion. It might be because the magma is seeping into the crust, or because this magma is heating up the Yellowstone hydrothermal system, making it expand and raise the crust. Yellowstone has the status of an active volcano. Its volcanic explosivity index is 8 out of 10. Such a high number means that if this volcano erupted, it would be an apocalyptic event. Right before the disaster, the ground around the national park would lift. Geothermal pools and geysers would heat up to boiling temperatures and get more acidic than usual. The magma would start to rise toward the surface. At some point, the rock roof of the magma chamber wouldn't be able to resist anymore, and the explosion would kick off. A massive column of lava and ash would shoot up to a height of over 16 miles. After that, the volcano would keep pumping ash for days on end. The mixture of lava, ash, and gas would be hotter than 1,800 degrees Fahrenheit. It would travel through the area at a speed of 300 miles per hour, faster than a racing car. The air near the center of the eruption would heat up to 570 degrees Fahrenheit. One of the most dangerous consequences would be ash fallout. Volcanic ash can turn into glassy cement within seconds after being inhaled and getting in the lungs. People and animals would have problems with breathing. Okay, so that's an understatement, just so you know. Buildings would start to collapse under the weight of this dense substance. It would take just several days until a 10-foot layer of ash covered the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. If the eruption was rich in sulfur, an effective sunblocker, it would get so cold there would be no summer in the entire world for the next several years. The monsoon seasons would change. Agriculture would face serious problems. There would be issues with food supplies. Over the past 50 years, the Yellowstone caldera has risen almost 2 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. The probability of the eruption is 1 in 730,000. Safe to say, it's a long shot. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. Still, there have been tons of discussions about what people could do to prevent the disastrous supereruption from happening. And the most popular and seemingly effective idea was to cool the Yellowstone supervolcano down. Unfortunately, there's a catch. The volcano leaks out only 70% of the heat which comes from its magma-filled chambers, but the rest of the heat stays inside. As soon as it reaches a particular threshold, the volcano erupts. If it was possible to extract at least 35% of the Yellowstone volcano's heat, the eruption could be avoided. The cooler the magma is, the thicker and stickier it gets. It stops being so fluid and doesn't try to get out to the surface anymore. After considering these facts, NASA scientists came up with a plan. They suggested drilling a 6 miles deep well and pumping down cold, pressurized water. The temperature of the water that would get back to the surface would be approximately 662 degrees Fahrenheit. This way, the heat would be gradually extracted from the volcano. And if a geothermal plant was built on the site, it would generate plenty of electric power. It would be very simple to produce, and its price would be very alluring, about 10 cents per kilowatt hour. At first glance, it was an amazing idea. But sometime later, it started to receive a lot of criticism. Imagine drilling through the Earth's crust, getting deeper and deeper, and then wham bam, you hit a hypothermal pocket. Uh-oh, get ready for a catastrophe. This can release gases that are likely to cause a series of super powerful explosions. In the worst-case scenario, it may even trigger a full-scale volcanic eruption. Now, you already know about its catastrophic outcomes, from fountains of lava and avalanches of molten rocks to climate changes all over the globe. Yeah, not good. Or let's say you're drilling a well to deliver cold water to the volcano, and then you suddenly hit its magma chamber. In this case, instead of cooling the giant down, you'll make the top of the magma chamber much more fragile than it used to be. And the whole construction will be at risk of collapsing at any moment. And don't forget that your drilling may also release toxic gases. They often accumulate at the top of the reservoir with magma. Can it get any worse? Well, yes it can. The whole process would stretch for more than 16,000 years. This method is too risky to cool the volcano down as fast as people would probably want. And scientists aren't even 100% sure that when the cooling system construction is finished, the volcano will stay cold for at least another 100 years. And last but not least, the project of making the Yellowstone supervolcano a bit cooler would cost a mind-boggling $3.5 billion. A huge price for something that might not work out altogether. Oh, by the way, Yellowstone isn't the only volcano that has a lava dome that's lifting at the moment. Lava domes are created when magma gets to the surface and then gathers around the vent. Scientists have found one of those inside an underwater volcano in Japan. This dome is more than 2,000 feet high and more than 6 miles wide. Even though the Japanese supervolcano seems to be sleeping, experts don't let their guard down. A volcanic system can go from being calm and docile to teetering on the edge of an eruption in the blink of an eye. Another massive dome is growing in the central Andes, on top of the planet's largest active magma store. The Altiplano Puna Plateau, well there's a tongue twister, and where the dome was found, is the second highest plateau in the world, and the dome itself is more than half a mile tall. You might wonder how come experts have known nothing about this enormous uplift until recently. The answer is simple. It was hidden within the plateau. It's an arid region littered with volcanoes, and it stretches for thousands of miles. Yep, another case of hiding in plain sight. Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other land masses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's eighth continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent's landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritius. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritia. They found a mineral that exists in rocks, which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Saul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species developed differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Saul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that. Okay, watch your step now. Millions of gallons of hot magma are gathering in one flow and rising thousands of miles to the surface of our planet. A massive fracture in a tectonic plate shakes the ground and fills the air with a loud hum. Fire, gases, lava erupt from the dark, unexplored depths of Earth's crust. A planetary-scale catastrophe has just happened, and no one's noticed it. Now imagine you're having fun on a luxury yacht somewhere in the southwestern Pacific Ocean, drinking cocktails and sunbathing. At this moment, one of the most powerful volcanic eruptions in the planet's history is happening right below you. But you don't feel anything. You don't even drop your glass. Yeah, you can hear a strange sound coming from the ocean depths. You see foaming water and pieces of pumice floating up to the surface. But it doesn't bother you much. So how did it happen that we missed such a powerful eruption in 2012? Why did scientists find out about it only a few years later? The answer is simple: water. An eruption of an ordinary volcano is a huge disaster. There are incandescent liquid metals and molten rock containing almost the entire periodic table inside our planet. All of this soup is called magma, and it's constantly boiling inside the subsoil of our world. This hot substance is lighter than the surrounding crust, so it always rises. Fortunately, the planet's surface is strong enough and doesn't allow magma to splash out. But sometimes this protection fails. The upper part of Earth is covered with connected parts, tectonic plates. These plates collide with each other and then move apart. Imagine a big moving mosaic puzzle where all its parts are tectonic plates. And when a small part of this puzzle gets separated from another, magma immediately comes up. These unstable fault sites with leaking magma are called volcanoes. And when they erupt, it gets hot. Lava flows out of the vent and burns all the vegetation around. This is accompanied by earthquakes and thick black smoke. If a volcano spits out magma too high, it falls back to the surface in the form of fire rain. But the worst thing here is ash. It's not that ash that's left in your grill after a good barbecue, no. Volcanic ash consists of solid particles harmful to any organism. These particles are not burnt wood, but various chemical elements. Volcanic ash is sharp, dense, and tangible. It can block sunlight, cover and destroy all plants, settle in your lungs. If you get too close to an erupting volcano, well, you better have a fireproof suit, oxygen tanks, a gas mask, and an underground shelter. Then you might survive, but there's no guarantee. At the same time, if an eruption occurs underwater, you don't need to worry about it. Of course, if you're not a marine biologist studying coral reefs nearby, or if you don't travel past that area in a submarine. In that case, boy, you're in trouble. When an underwater volcano erupts, this shakes a colossal area, heats the water, destroys the seabed. But almost nothing happens at the surface. The enormous pressure of millions of gallons of water suppresses the destructive power of the volcano. Molten rocks shooting out of Earth's crust get pressed against the seabed. Yeah, a submarine swimming by would be thrown off course and might collide with solidified lava. Fortunately, no such cases have ever been recorded, but it can easily become a reality because underwater eruptions happen pretty often. More than 70% of all volcanic activity occurs underwater, and almost no one notices it. In most cases, these volcanoes immediately fall asleep after they erupt and never wake up again. But in 2012, something happened, and scientists couldn't ignore it. Big pieces of pumice, the size of a van, began floating up in the southeastern Pacific Ocean. These rocks covered about 154 square miles. There were thousands of them. They looked like a group of unknown floating mini-islands. Volcanic stones were scattered in the ocean over the area twice as large as New Zealand. Scientists determined the full scale of the disaster with the help of deep-sea sonar devices. They studied the seabed at a depth of 4,000 feet for a long time and found 14 craters from which magma had flowed during the eruption. The seabed was covered with frozen lava flows and tons of ash. The researchers found that more than a third of the erupted volcanic material surfaced and was scattered all over the place. The rest remained at the bottom. This wiped out all marine life in the area. It seemed that this eruption was one of the largest in the entire history of observations. But in 2019, researchers discovered something even more significant. That was an underwater volcano 3 times higher than the Eiffel Tower. According to scientists' calculations, it ejected between 30 and 1,000 times more molten rock than the previous volcano. This monster had been feeding from the world's deepest magma reservoir we know about. Seismic activity here was so devastating that it destroyed everything around. Fortunately, not for long. After any eruption, life reappears like a phoenix rises from the ashes. And it's not just a figure of speech. Volcanic ash and lava around the volcano contain many useful mineral elements. All of them nourish the soil and help microorganisms develop on land and in the water. For this reason, there's usually so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form islands. This is a long process that ends with the appearance of a massive piece of land above the water surface. To understand how this happens, you need to go back millions of years. So, let's go. See this underwater volcano? There are sea dinosaurs, giant sharks, and ancient fish swimming around. Now, the seabed starts shaking. The volcano releases tons of magma and ash. The water pressure immediately pushes all this stuff back to the bottom. The eruption can continue for a long time. The released magma raises the seabed. After hundreds, maybe 1,000 years, a new eruption begins. New magma flows create a new layer above the previous one. Over millions of years, layer by layer, the volcano is growing. It's slowly rising, thanks to constant eruptions. Of course, with time, some volcanoes go dormant, but this one continues to erupt. And then, one day, the volcanic rock reaches the surface and an island emerges. After many more years, the volcano can fall asleep. After this, life is likely to appear on the island. Grass, flowers, trees, animals. The area that was once ruined seabed is swarming with life now. Volcanic islands have unique ecosystems because they develop separately from all the continents. Observing such islands helps scientists understand how life on Earth evolves. New species of birds, animals, insects can live on these chunks of land. Hundreds of islands around the world appeared thanks to eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, Iceland. Many of them are inhabited by people who build villages and towns there. There were cases when a volcano erupted when people literally lived on top of it. That's what happened on the small island of Aogashima, located to the south of Tokyo. People built a beautiful town right in the crater of an active volcano. And in May 1785, an eruption began. Nobody expected this to happen. At some point, thousands of birds rose in the air and flew away from the island. Then the ground began to shake. A heavy, low sound shook the air. Thick smoke appeared above the top of the green volcano. The crater started spitting dirt, huge rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People somehow managed to evacuate. Then, finally, the volcano calmed down. After that, a long process of recovery started. The inhabitants of the town rebuilt houses, roads, infrastructure. More than 200 years have passed since that moment, and during this time, the volcano never woke up. And despite the risk of a new eruption, people continue living there. The population is growing. Many people from other cities and countries come to live there. The main reason everyone loves this place is that it looks like a paradise. Nobody wants to leave the island. There are thermal springs where you can bathe, dense jungle with many beautiful animals and trees. The soil is rich, and you can grow tasty fruit and vegetables there. The water near the coast is swarming with fish. Every day, you can enjoy the incredible landscapes of the island. Seismological services constantly monitor the situation and watch the volcano's activity, listening for a rumble that may someday come again.
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zirkon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research, but this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some Craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zirkon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritius, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritius was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritius was covered in water when India broke away from Madagascar, something like 85 million years ago.
Ah, Kiev, you've been dreaming of getting here for years. Getting out your trusty camera, you start taking pictures of the cathedrals, aviation museum, and the Dnipro River, when, without warning, there's an enormous boom behind you. Turning around, you see something towering in the distance. It looks like a gigantic explosion. Uh-oh, time to leave fast. In June 2020, what the people of Kiev were looking at was an anvil cloud, a rare storm formation in the sky. Forming when strong air currents carry water vapor upwards, the air expands and spreads out as it hits the bottom of the stratosphere. It pushes the dense cloud into the cool anvil shape you see, and sometimes it even gets to be a mushroom. Anvil clouds produce some of the most dangerous lightning of all storms, one that's called a bolt out of the blue. This lightning strike seems to magically come out of the blue sky with the storm being many miles away. This type of bolt comes from the top of the anvil and can be 10 times more powerful than a typical lightning strike. People got so frightened after witnessing a giant cloud just 60 miles away, thinking something terrible must have happened. The locals had pictures of the large billow on social media before officials could explain what was going on. Authorities managed to calm everyone's fears by informing them it was nothing more than a natural phenomenon, and a beautiful one at that. Before dissipating, these clouds typically stay in one area, regardless of how strong the wind is. Touring around the northern tip of Queensland, Australia, way away from those creepy crawlies, it's time to take a break and relax at the beach. Getting comfortable, you notice a great big shadow passes over you, then another, and yet another. Looking up, this weird weather is simply stunning. The clouds are called morning glory, a very rare type of cloud that almost seems to roll across the sky, looking like a massive tube. These clouds can measure up to 600 miles long, even appearing in large groups as well. This phenomenon is the result of an updraft pushing through the cloud, creating a rolling appearance, while moist cooler air at the back causes them to sink downward. Southern India between July and September 2001. People witnessed one of the strangest weather phenomenon in recorded history. The rain was red. What many would have thought to be a typical rainstorm left them shocked. The color was bright enough to stain clothes. There were other colors too, such as green, yellow, brown, and even black. In the middle of a monsoon, red rain started to fall, and did so periodically for several weeks. Researchers have found this unusual rain is stained either by dust or algae, so don't try to catch any on your tongue. Scientists aren't entirely sure how the algae got all the way up there. This does make events like this a little unsettling. Like to take a bubble bath to relax after an exhausting day, but taking too long to fill the bathtub? Problem solved. Head to any coastline after a big storm and take a dip. Foamy tides aren't native to any one place or location. They can be formed anywhere in the world. They're most likely to happen along rocky coastlines, like the coast of San Francisco, Northern Ireland, or the Mululaba, Australia. Each coast has differing conditions forming the sea foams. If you scoop up seawater into a glass and look at it closely, you'll see it's full of tiny particles. Many things like plants, chemicals, and lots of salt and minerals create the perfect formula for foam. When powerful currents and wind mix it all together, we get something that resembles a cappuccino top floating on top of the water. When freezing temperatures hit orchards in Michigan, all kinds of unusual things happen, like ghost apples. No, they're not going to scare you at all. But if you plan on sneaking away one winter to find one, be warned. Everything has to be perfect for this to occur, and it's going to be freezing cold. This is actually a rare weather phenomenon caused by having the apples freeze where they are with rain coating the fruit in a thin layer of ice. The apples then thaw and leak out like applesauce, leaving just the beautiful ice shell behind. The Catatumbo River in Venezuela might be the most electric place in the world, with nearly 300 storm days per year. The lightning storms are so consistent, they're predicted for 3 months in advance. During the wet season in October, you might see 30 lightning flashes in a single minute, a truly shocking experience. With each bolt having the energy to power a single light bulb for 6 months, the impressive display could power all of Venezuela forever. At sunset, strong winds flow around the 3 surrounding mountains, forming storm clouds over the water. As the water droplets of humid air collide with ice crystals from the cold air, it produces the static charges that cause the lightning storms nearly every night. If that wasn't bad enough, some storms have lightning above them as well. Try to take a picture of this one. Jellyfish lightning sprites are electrical discharges high in Earth's atmosphere. They're associated with powerful thunderstorms, but they have nothing to do with rain. These sprites occur 30 to 50 miles up in the sky, in the mesosphere. Artificial lights at night make it a lot harder to see this faint lightning. If you spot one, it'll look tiny, but can be well over 30 miles wide. The red sprites are a type of cold plasma discharge above a thundercloud. They're the balance of the lightning charges between the storm clouds and the ground below. Don't try to find this type of donut at your favorite bakery. It won't be there. Snow donuts are one of the rarest meteorological sights to see, with perfect weather conditions needed just to create them. Found in any snow-covered mountain area, like the Rocky Mountains, the wind, temperature, snow, ice, and moisture have to all work together for us to see these phenomenal rings. A thin layer of wet snow on the ground. Under that layer, ice or powdered snow. Then, a strong enough breeze to roll the donut down a hill, just like a snowball. Once it stops rolling, it can be the size of a baseball or as large as a car tire. It all depends on how strong the wind is. A newly formed snow donut won't stay around for very long, so hurry up with that camera. Watching the sunset over the horizon, the beautiful purples and pink overhead are nothing compared to the 3 suns you see in front of you. Wow, since when did Earth get 3 suns? These phantom stars sometimes appearing beside the sun are called sundogs. Maybe they're called that because they're kind of dogging the actual sun? Sundogs often appear as colored areas of light at the same height above the horizon as the sun. They're mostly observed on a ring or halo, where ice crystals best reflect the light. There are also moon dogs that appear alongside the moon and are formed by lunar light passing through ice crystals, though these aren't seen nearly as much as their daytime partners. Taking photos in the wild, you finally found the perfect spot to take that dream shot. The crystal clear water, the pines, the mountains, and the flying saucer. Wait, a flying saucer? Oh, aliens are here! You might be thinking this if you saw a saucer-shaped cloud. I'm not even going to try to pronounce their name though. Put that on the screen, please. Wait, just kidding. It's altocumulus lenticularis. Aren't you impressed? These are really just unusual cloud formations over mountaintops. When moist air flows over a mountain, a wave is created if the temperature difference is perfect. As the air passes through the wave, evaporation occurs and a series of these clouds may form into an oval shape. Not aliens at all. Whew! The sky is falling! The sky is falling! Well, people who have experienced these clouds say they look like they're coming down from the sky. Mammatus clouds look like giant white lumpy marshmallows, but it might be hard to toast these ones. These weird fluffy clouds can extend hundreds of miles in any direction, remaining visible for short periods at the bottom of anvil or other thunderstorm clouds. The strange bubble shapes are formed from turbulence within the storm itself, creating an uneven cloud base and appearing anywhere in the world. Mammatus clouds form when moist air sinks into dry air. The air must be cooler than its surroundings, cooled with ice, or be heavy with water.
One of the few places you haven't traveled to yet is a volcano. It's an opening in the Earth's crust through which hot gases, molten rock, and other stuff get to the surface of the planet. But which one should you choose? There are different kinds of them. For example, shield volcanoes are built almost entirely of solidified lava flows, or lava domes formed by small masses of lava that are too thick to travel great distances. You can also pick a cinder cone. It's the simplest kind of volcano out there. It's built from blobs of almost solid lava that erupts from a single vent. This lava is ejected into the air with great force. Then it breaks into tiny fragments that become solid and fall back as cinders. With time, they form an oval or circular cone around the vent. Such cones rarely rise more than 1,000 feet. But what if you choose something even more impressive? How about traveling down a stratovolcano? Huge, steep-sided, and powerful. Once you've made your choice, you also decide to opt for an active volcano that is erupting at this very moment. What you're observing now is called a glowing avalanche. The volcano has just erupted a huge portion of lava, which has created a pyroclastic flow. Its temperature can reach an insane 1,300 degrees Fahrenheit. You see how this flow gets formed from rock fragments and surges down the flank of the volcano at a speed of several hundred miles per hour. Ash is raining down on Earth like grayish, powdery snow. Volcanic ash consists of tiny particles of pulverized rock, volcanic glass, and minerals. When the ash gets mixed with the water from mountain streams and rivers, raging mud flows appear. Despite how scary it all looks, you get closer. Good thing you're wearing a protective suit that can withstand any temperature. The nearer you get, the more fumaroles you spot. These are holes and cracks at the base of the volcano and in its slopes. They emit huge clouds of steam and volcanic gases, carbon dioxide and sulfur dioxide. Some of the cracks are so large, you can probably squeeze through and sneak a peek inside the volcano. But you have a different destination, the crater. On your way there, you spot a strange conical structure on the side of the volcano. It looks like a horn growing on the main cone. It must be a secondary cone, also known as a parasitic cone. Such cones form around secondary vents that reach the surface of large volcanoes. In this case, an eruption can occur not only through the main vent at the top of the volcano, but also through these additional vents. In any case, that's not where you're heading. Soon, you reach the crater. It's a massive circular basin. When you go to its edge and look inside, you see it's also very deep. The lava vent, which is where you need to go, is at the bottom of the crater. But even before jumping into the vent, you spot some strange tubes hiding under the lava flow. Those are lava tubes, natural passages through which fresh liquid lava travels beneath the surface of the lava flow. You decide to make a detour and follow one of the tunnels. It's the main lava tube. You also spot several smaller tubes. They supply lava to one or more lava flows. If the volcano wasn't erupting at the moment, the lava would drain downslope from this tube system. The passages would have lava marks on the walls, a flat floor, and lava stalactites hanging from the ceiling. But even now, there's some empty space above the flowing lava. That's because it has eroded downward, making the tube deeper. But right now, you need to get back. You take the next turn and get back to the crater. You wait till the volcano spews another portion of boiling lava and dive into the volcano's throat. It's the entrance of the volcano. Lava and volcanic ash get ejected from here. The volcano's throat is wide, and you easily travel deeper down. The lava around you glows bright red and orange. That's because when it first bursts to the surface, its temperature can reach 2200 degrees Fahrenheit. That's hot enough to melt iron. You move down the volcano's main vent. It's a weak point in our planet's crust. There, scorching hot magma manages to escape from its chamber and reach the surface. While going deeper and deeper into the vent, you notice sills. Sometimes, lava intrudes between the crack in the crust, pools there, and crystallizes. This creates deposits of ash and solidified lava. That's what sills are. Pretty soon, you reach a magma chamber. It's a large pool of molten rock. The one you're in at the moment is quite shallow. That's because it's not the main one. After traveling several more miles down through the vent, you get to another huge magma chamber. It supplies the small one beneath the base of the volcano. The main magma chamber lies in Earth's crust, which stretches from 3 to 44 miles deep. The molten rock there remains under extreme pressure, and the temperatures inside are incredibly high. With time, the rock surrounding the magma chamber starts to break and fracture. This creates outlets for the magma, and since it's made of a much less dense material than the surrounding rock, the magma begins to seep through the cracks to the surface. From the main chamber, it rises to the upper one. Then it makes its way to the surface in a powerful eruption. You explore the magma chamber and then decide to go even deeper than that, to the place from where all that molten rock gets into the magma chamber. You're moving through the crust. The volcano is located on land. That's why your trip takes longer than it would if you were traveling through the oceanic crust. It's only 3 to 6 miles wide. But the continental crust is much thicker. It can be 28 miles thick in some places. As you're going through the crust, you can't but notice its light color. That's because it consists mostly of granite. If you were going through the oceanic crust, the material surrounding you would be dark or nearly black because it has a different composition. The deeper you go, the hotter it becomes. Sure, the temperature here isn't as high as in the magma chamber, but still, at the boundary with the mantle, your thermometer shows 750 degrees Fahrenheit. At a depth of about 20 miles, you reach the boundary between the crust and the Earth's upper mantle. There, the pressure reaches a mind-boggling 10,000 atmospheres. That's where magma comes from. You could finish your journey and get back to the surface, but your curiosity gets the better of you. You decide to go deeper, all the way to the center of the Earth. The next layer on your way is the mantle. It makes up 2/3 of the Earth's mass and 84% of our planet's volume. It's 1,800 miles thick. The rock closer to the inner part of the mantle is semi-solid, like caramel candy. The upper part of the mantle, as well as the crust, is broken into massive pieces. They look like a colossal jigsaw puzzle. Those are tectonic plates. They drift at a speed of 1 to 2 inches per year. You're moving through the upper mantle and feel the temperatures rising up to 1,600 degrees Fahrenheit. Near the boundary with the core, the temperature is already as high as 7,000 degrees Fahrenheit. The pressure in the lower mantle reaches 240,000 atmospheres. You'd feel the same pressure if 3,300 elephants made a tower on your head. At a depth of about 1,800 miles, you see the boundary between the mantle and the outer core. The insides of the planet around you are heated up to 9,000 degrees Fahrenheit. Such temperature is high enough to keep the outer core liquid. The pressure there is almost 2 million atmospheres, but it's not enough to make the iron that the core is made of solid again. The outer core is 1,500 miles thick. It churns in massive turbulent currents and generates a magnetic field. In the outer core, Earth's magnetic field is 50 times more powerful than at the surface. You are now more than 3,000 miles underground, and you've reached the inner core. It's a solid metal sphere, around 1,500 miles across. The inner core is immensely dense and spins faster than the rest of the planet. The temperature there is as high as on the surface of the sun, 9,800 degrees Fahrenheit. And the pressure inside the inner core is 3 million times greater than on the surface. It took about 500 million years for the inner core to form, which means it's younger than some parts of the crust. Doggerland? No, it's not a country of dogs, as you probably first thought. It's a land the size of Great Britain in the north of Europe. But don't bother trying to find it on the map of the old continent. Your search will come back empty. Doggerland hasn't existed for thousands of years. But where was it exactly? And did humans live here? Scientists are doing their best to answer these questions. Let's start with the name. In the 1990s, a British archaeologist named the area Doggerland after Dogger Bank, a sandbank some 60 miles off the east coast of England. The word probably comes from Dutch. It was used for a fishing boat with 2 masts. Makes sense, since today, the North Sea is a rich fishing area. But thousands of years ago, people living here had a different diet. Some 12,000 years ago, the last major ice age was slowly reaching its end. Doggerland didn't feature seawater, but marshlands, lagoons, forests, and gently sloping hills. At that time, Britain and Ireland weren't islands. They sat deep inland. You could set off in Denmark and walk all the way to the north of Scotland. There was a system of rivers that emptied themselves in the North Sea. Back then, it was more of a channel that separated Doggerland from Norway. The rivers were different too. The Thames flowed into the Rhine. The ancient river they formed flowed into the place of today's English Channel and emptied itself into the Atlantic Ocean. Doggerland even featured a lake. There were some glaciers as well, but the land was still inhabitable. So who lived there? There were communities of hunter-gatherers from the Middle Stone Age. This was the time of human history when our ancestors mastered chipped stone tools. They used these stones with sharp edges for spears and arrowheads. This came in handy at Doggerland, which was the richest hunting area in all of Europe. It could have easily been the most populated region in the northwestern part of the continent. The hunters' prey likely consisted of reindeer, mammoths, oxen, wild pigs, brown bears, wolves, and many other species. In short, nobody went hungry here. Meat wasn't the only thing on the menu. Ancient residents of Doggerland collected hazelnuts and berries. They lived in wooden huts. They built them close to rivers, and they even constructed their settlements on hills. Remember Dogger Bank? It now sits underwater, but it used to be a mountainous region. Doggerland must have been prime real estate in prehistoric times. Its total surface area was over 18,000 miles, but things were about to go under, literally. The last ice age was ending. All the water trapped in glaciers and ice sheets started to melt. You experience this process firsthand every time you order a cold drink. Even if you drink it bottoms up, after a while, the glass is full again. Why? Because the ice cubes have melted. Think of Doggerland as that glass. The sea level started rising quickly. Every century, the sea flooded from 3 to 6 feet of dry land. Just imagine what this would mean today. Miami's elevation is just over 6 feet. The city would be flooded in less than 100 years. But there was one event that speeded things up. The Storegga Slides were a series of submarine landslides in the Norwegian Sea thousands of years ago. And what happens when huge chunks of Earth shift suddenly underwater? Gigantic waves. You probably know what a tsunami is. Doggerland was likely pounded by several of them. They were so powerful that researchers believe they washed away Great Britain's land bridge to the rest of the continent. All that was left of Doggerland was an island the size of Wales. Scientists estimate that the waves of this ancient tsunami were at least 40 feet high. Some 6,000 years ago, Doggerlanders were on the move. They were migrating to higher grounds, England and the Netherlands in their case. The ironic part is that when we literally translate the name of the country of Netherlands into English, we get lower lands. But thousands of years ago, this was higher ground for hunter-gatherers escaping the flood. Once it was all over, the continent of Europe got the shape we easily recognize today. But Doggerland was nowhere to be seen. It's been sitting under the waves of the North Sea for 8,200 years. Does the idea of Doggerland remind you of a more famous case of a submerged land? The lost city of Atlantis comes straight to mind. But there is an important difference. Atlantis is only a legend. Everything we know about it comes from the writings of the Greek philosopher Plato. Scientists have been searching for Atlantis for a long time. And, up to this day, they can't even agree where exactly it was. Theories range from the Mediterranean to even Antarctica. Doggerland is not a myth. Everything science knows about this lost land comes from hard evidence. In 1931, a fishing boat was doing its thing off the coast of Norfolk in England. At the time, the crew would drag a net along the sea floor, sweeping everything in its path. And they caught something more than fish. It was peat, like the stuff we find in Alaska and in Ireland. But what was it doing at the bottom of the North Sea? It didn't belong there, because seawater destroys peat. There was only one possible explanation. The area must have been dry land at some point in history. The final proof was that the peat contained a harpoon spear point, a sure sign of human activity. The idea wasn't new, though. Since the Middle Ages, there has been talk of submerged land with underwater forests. In 1913, a British geologist came forward with the idea of an undersea world in this part of Europe. Scientific evidence kept piling up. Local fishermen started pulling out human-made tools and animal bones. Researchers dated them to be around 9,000 years old. But the deep, murky waters of the North Sea made it impossible to send down divers. One archaeologist noted that they knew more about the surface of the moon than what lay at the bottom of this relatively shallow sea. The discovery of oil in the area in the 1960s was a real game changer. Companies from the industry provided seismic survey data to scientists. This helped them piece together the full image of what Doggerland used to look like. Computer models soon produced images of river valleys, coastlines, freshwater lakes, and hills. There are even footprints of nomadic tribes preserved on the sea floor. Today, marine biologists are using magnetic fields to map out this lost underwater world. But Doggerland isn't the only place on Earth that went under the waves. Beringia is another lost world of global importance. This used to be a land bridge between Asia and North America. It got its name from the Bering Strait. It is 53 miles wide at its narrowest point. But until the end of the last ice age, this was dry land that our human ancestors called home. Genetic evidence shows that Native Americans lived in Beringia for some 15,000 years. If you want to imagine what this land looked like, think of present-day Arctic Alaska. It was a shrub tundra. There were also small willows and birches. Sorry, no woolly mammoths. Large grazing animals simply wouldn't have had enough food in Beringia, though there were probably elk and bighorn sheep in the area. But the Ice Age wouldn't last forever. Like in Doggerland, sea levels started to rise. This happened some 13,000 years ago. It wasn't all bad news, though. Scientific evidence suggests that around this time, people started moving south. They left the slowly sinking Beringia and crossed over into Alaska. From there, they populated both Americas. These were the ancestors of Native American tribes.
In 1996, one of the most vigorous snowstorms in history hit the east coast of the U.S. It was named Blizzard of 1996. From January 6 till January 8, a huge amount of snow fell in the country. The storm was so strong that people couldn't see anything around except a white veil. Huge snowdrifts formed. People couldn't leave their homes because snow had covered all the doors and windows. Someone spent hours shoveling snow to get into the car. And while they were doing this, new snowdrifts appeared around. This is considered one of the main winter storms of the 20th century. Schools and universities didn't work. Shops, libraries, and cafes were closed. You could look out of the window and see nothing but a white ice wall. The wind lifted snow into the air and blocked the movement of cars. People abandoned their cars to hide in the nearest shelter, which created many miles of traffic jams. During the snowfall, hurricanes formed and destroyed buildings. Chaos reigned everywhere. People were afraid to leave their homes. Strong wind and rain forced rivers to come out of their mouths, which caused massive flooding in nearby cities. Many states lost millions of dollars because of the destruction. However, at that moment, the residents of one small town didn't notice the problem. The blizzard of 1996 covered almost all of Pennsylvania, but the weather was not so bad in Delaware County, aka Delco. Neighboring cities were attacked by the storm, but not this one. Since about that time, a legend has appeared among the locals. They say their small town is protected by a mysterious weather bubble. In 2013, they called it the Delco Bubble. According to the locals, the bubble covers the entire Delaware County and protects it from all natural disasters and other hazards. Residents of a quiet, sunny town like to talk about this phenomenon, but there's no scientific evidence of its existence. It seems bad weather bypasses the district during huge storms. As soon as the hurricanes approach this place, they break up in different directions and then converge right after passing this area. All this happened according to the locals' words, without meteorological evidence. They remember several different storms in the 90s, including the blizzard of 1996. They announced that the storms would reach Delaware on TV and radio, but in fact, no forecast came true, and the residents enjoyed pleasant weather. One resident says that he often looks at forecasts and satellite photos and sees how black clouds disperse in Delco. It's peaceful and comfortable here. It seems as if time has stopped here too. However, the bubble doesn't protect against all problems. There were some floods there, after all. So, many residents don't believe in anomalous protection. There's one scientific explanation proving that storms are weakening in this place. Sea breezes go inland and settle in places like Delaware County sometimes. The streets and surroundings are filled with cold air. This creates air stabilization. Then when a storm forms and goes here from the west, it meets this stabilized air mass. Hurricanes lose a significant part of their strength, so it seems as if bad weather simply bypasses the district. Also, the Delco bubble can be explained with the help of psychology. Almost all rumors about the protective anomaly come from people. Residents write on social networks and tell each other about how the hurricane didn't touch their homes. In such cases, people often think that if trouble didn't happen to them, then it didn't happen at all. Imagine you go out on the porch of the house while the radio predicts a strong storm. Everything is calm before your eyes. A light breeze blows in your face. But behind, a few hundred feet away from your backyard, a real hurricane is raging. You didn't see it and went to write a post on the internet that the Delco bubble saved your city again. Storms are a dangerous weather phenomenon, and you should be wary of them, especially if you don't live inside a protective bubble. But let's say you missed all the news and reports about an approaching thunderstorm. It's okay. You'll know it's approaching you thanks to the clouds. One of these clouds is called cumulonimbus. These are precursors of thunderstorms, hurricanes, hail, floods, and even tornadoes. You will easily recognize them by their formidable appearance. They are thick, heavy, dark, and can sparkle because of the lightning created inside. The first reaction to such clouds is to escape or seek shelter. But wait a minute. Let's see how they form. The warm air lifts the smallest drops of water. They are so tiny that they form steam. Most often, this steam rises from the ocean. Since there are several times fewer of them on land, they rise high into the sky in an area with a very low temperature. There, the warm steam cools down, and the droplets turn into tiny particles of ice. Then, these frozen pieces are mixed with other particles that the planet is filled with: dust, ice, and sea salt. All these things stick together into a homogeneous mass and create a cloud. Millions of other extra particles stick to it, and the cloud becomes more voluminous. The mass increases and drops begin to fall to the ground in the form of rain. Clouds are necessary for the planet. They protect us from the strong radiation of the sun's rays. You could say they filter the sun for us. When night falls, the clouds act as a blanket. They keep warm and don't allow the cold to penetrate inside. Almost all clouds are formless. The human imagination comes up with what they look like. But there are rare clouds that have a clear, striking shape. Lenticular clouds. They are stationary and have the shape of a huge round plate. These clouds often cover mountain peaks. Mammatus cloud. They often form under cumulus rain clouds. They look like hundreds of huge bags filled with water hanging over the ground. If the sky looks like gasoline is spreading all over it, you see nacreous clouds, common for areas with rather low temperatures. You can see it in places closer to the Arctic Circle. They get this color thanks to the sun. It shines on the clouds at a certain angle and creates this pattern. Morning glory clouds are like huge ropes stretching along the ground. You can observe this phenomenon in northern Australia. So let's go down from the clouds to the ground and look at the mysterious phenomenon hiding among the swamps. For centuries, people have been observing this strange thing. Some called it fool's fire. At night, somewhere far from civilization, you can see mysterious bright lights among forests and swamps. They glow with orange and blue colors. It seems like somebody has lit a torch and now is waving it to attract your attention. Perhaps someone needs your help, and they are signaling about it. In the past, people thought so too. They walked towards the lights and found themselves in the swamps. Now, they needed help, but there was no one around, and the mysterious lights just disappeared. Walking through swamps is very dangerous, so don't let these lights catch you in this trap. You should know that there's a scientific explanation for this phenomenon. Bioluminescent fungi and algae grow in swampy places and sometimes glow with a blue color. From afar, this creates the illusion of a small light. Wind and water sway algae with mushrooms, so it seems as if lights are flying. Also, there's a lot of organic material in the swamps: leaves, grass, mud, clay, tree branches. This stuff decomposes rapidly in wet conditions and releases methane. As soon as the methane comes into contact with the air, it ignites and flies over the swamp in the form of a burning ball. This phenomenon is observed all over the world in swampy areas, but the most famous flying lights are in the West Texas desert. They are called Marfa lights. Each of them is the size of a basketball and always appears in the desert. The lights flicker, merge, divide into two parts, fly away into the sky. However, there's no scientific explanation for this phenomenon. Maybe these are just lights from passing by cars. However, many people think that Marfa lights appear for the same reason as spook lights over swamps. There are large reserves of oil and natural gas with methane hidden under the desert. Sometimes, this gas comes out of the ground and gets fired after contact with oxygen.
Around 5.3 million years ago, a crucial event reshaped the Mediterranean region. It was a colossal flood that refilled the local sea, which had been extremely barren and salty up until that point. It got the name Zanclean Flood, and it forever changed the geography of the area. The Mediterranean Sea is surrounded by Europe, Africa, and Asia, and connects to the ocean by the Strait of Gibraltar. This is quite a narrow passage, measuring about 8 miles. It may not be that wide, but the strait plays a crucial role in maintaining the liquid balance between these two bodies of water. About 6 million years ago, a bunch of things might have caused the Mediterranean to be cut off from the Atlantic Ocean. Some say it was an ice age. Others speak of tectonic movements, like earthquakes. Whatever the cause, it pushed the Mediterranean area into a period called the Mycenaean Salinity Crisis. For about 1,000 years, the sea slowly evaporated, leaving behind a dry basin that was several miles below sea level. This crisis really changed the landscape, creating conditions similar to those found in today's Dead Sea. What this means is that the lush Mediterranean beauty used to be a super salty environment, containing nearly 10 times more salt than the ocean. Say you could have visited. you would have been able to effortlessly float on the little water you could find, even if you're not a skilled swimmer. The amount of salt and that mineral content would have made it challenging for most creatures to survive. However, some hardy microorganisms, such as bacteria, could have adapted to these harsh conditions. These days, at the bottom of the Mediterranean Sea, we can find holes as large as the Grand Canyon, and they seem to have formed during that same period of dehydration. Evidence suggests that massive rivers, such as the Nile and the Rhone, flowed directly into the Mediterranean back then, leaving behind canyons as they reached the bottom, thousands of feet below the sea level. People had to find some sort of explanation back in the day for the drying of the Mediterranean, so they came up with myths and legends. One such tale was told by the people of southern Iberia, in modern-day Spain and Portugal. It was also recounted by a famous Roman writer called Pliny the Elder. What this legend said was that the Mediterranean used to be cut out from the ocean until the hero Hercules, with his mighty sword, carved a path. He did so between a fictional location in modern-day Africa and the Rock of Gibraltar. This allowed the ocean waters to flow in, transforming the Mediterranean into what we know today. Some fossils also seem to confirm the unusually large flood. Remains of marine organisms were found in layers high above current sea levels. This means the areas were once submerged underwater. These fossils belong to mollusks, fish, and marine mammals. Because of modern techniques, we now have at least an estimated timing of the Zanclean flood. Scientists used computer simulations to reconstruct the event, providing further evidence that it was real. What they also discovered is that there's a possibility the Mediterranean might change once more. The Strait of Gibraltar could close, most likely because of movements deep under the ground. This could lead to the Mediterranean becoming dry again, over a span of about 1,000 years. The Mediterranean area could disappear altogether if the African continent keeps shifting north too, getting closer to Europe. Another one of those famous yet still a bit hypothetical large floods is called the Black Sea Deluge Theory. Some scientists think that around 8,400 years ago, water from the Mediterranean might have spilled over into the Black Sea through a narrow passage called the Bosporus Strait. This could have caused a massive disaster, forcing people living near the Black Sea to pack up their things and move further inside the continent, in both Europe and Asia. Along with them, they might have carried stories about this colossal flood. The specialist that came up with this idea also suggested that these migrating people might have brought along new ways of farming. Not everyone from the scientific community is convinced though. Some argue that while there might have been a flood, it likely happened earlier and was way smaller. They didn't think this flood could have caused, for example, the story of Noah's Ark. In this legend, a spiritual man was warned by a higher entity that a giant flood was on its way. The man went to gather pairs of animals and pack them all in a boat to make sure these species would survive the devastating flood. There was also the concern among scholars that discussing real floods and ancient stories too much might blur the lines between science and fiction. There may be other reasons why these flood stories are so often found across different cultures all over our planet. One idea is that floods were incredibly destructive for early farmers, so they invented myths about them signaling the end of the world. Another idea is that people stumbled upon ancient sea creature fossils in unusual places, leading them to believe there was a significant flood in the past. The solution to future floods, though, might be floating cities. As sea levels continue to rise, coastal cities like Amsterdam, New Orleans, and Venice may go under. So, floating infrastructure may be the way to go, with buildings that can rise with the water levels, making them able to resist extreme weather too. Countries like the Netherlands, which have a history of managing water risks, are pioneering these floating creations. With cities running out of space for expansion, we might be forced to move on water anyway. By moving on the water, we can reduce crowding and create more interesting ways to feed ourselves, like floating gardens. These homes also come with great alternatives to our energy needs through systems that use solar and wind power. Not to mention that these homes might turn out to be cheaper in the long run. One such floating city might pop up soon in the Maldives. Its goal is to host up to 20,000 people and will feature places to live and eat, but also shops and schools. Designed to look like coral, the region will include canals placed between some 5,000 floating pieces of land. The city will be constructed using modular units, put together in a construction site nearby. After they're completed, they'll be towed to the floating city. The next step is to secure them to a large underwater concrete hull, which is screwed tightly to the seabed on some steel stilts. All these pieces of construction let the modular units easily move as naturally as the sea. Even for those that are afraid of seasickness, there's a solution. That's what the nearby coral reef is for. It will surround the city, making a natural wave breaker. Human-made coral banks will also be placed underneath the city, which will also help coral grow naturally. The long-term goal is to make the establishment self-sufficient. It will have electricity, mostly from on-site solar power. Waste will be treated nearby and reused as plant fertilizer. Instead of air conditioning, the city will use deep-sea water cooling. This method pumps cold water from the deep sea to cool the area, saving energy. Earth is not the only planet that's seen some serious floods. In ancient times, Mars seems to have experienced them too, and they played an important role in shaping its surface. Recent research reveals that billions of years ago, Mars was heavily affected by some serious river flooding, which contributed to the formation of its valleys and canyons. The reason for these floods was heavy rainfall, which reshaped the Martian landscape in a jiffy, at times even within days or weeks. Unlike Earth, where rivers form pretty slowly, Mars experienced rapid changes because of these floods, particularly around 4 billion years ago. We've known for quite some time that there have been floods on Mars, but this study really showed us their extent. We now know they were more widespread and frequent than previously thought.
Urbania sounds like a made-up city from a fairy tale, but it's not. It's real and located in central Italy. The town's name isn't the only strange thing about it. Every year, the local newspaper and television publish a strange weather forecast. It's based on onion wedges. Yes, you've heard it correctly. Italians from this region eagerly look forward to a forecast based on a vegetable. The tradition dates back to the Middle Ages. It's kept alive by the local school teacher. Every January 24th, she cuts a yellow onion into quarters. Then, she divides them into wedges, 12 of them for each month of the year. They lie neatly on her kitchen cutting board, facing east. The following morning, the onion is ready for interpretation. Because she sprinkled them with salt, the wedges change their texture. The woman uses these clues to forecast the weather for that year. She's been doing this for 3 decades. And before her, her father did it. Before him, her grandfather. You get the gist. Onion reading has become a family tradition. Historical records show that this practice has been going on in Urbania for centuries. Back in the day, farmers used this method of forecasting the weather to help agriculture. It was important to know exactly when to plant seeds and when to harvest crops. The method must have been accurate because up until the beginning of the 20th century, locals still trusted onions more than the official weather forecast. This isn't surprising. The first weather forecast based on scientific data was published in a British newspaper in 1861. Before this time, people did all sorts of things to predict the weather. The methods they used might seem pretty funny to us today. Take the woolly bear caterpillar as an example. This species lives in the United States and southern Canada. The legend goes that you can determine how harsh the next winter will be just by looking at the animal's color pattern. If the color brown is dominant, then the winter will be mild. That's an odd way to predict the weather, but believe it or not, it does have some grounding in science. You know who entomologists are? Yes, those are scientists who study bugs. Their research showed that the caterpillar's color is connected with how much food it has had. But there's a twist. The color reveals the harshness of the winter of the previous year, telling the future is not the woolly bear caterpillar's forte. People think ladybugs bring luck, but they're more than good luck charms. Have you ever heard of the saying, "When ladybugs swarm, expect a day that's warm"? This is actually true.
When the weather is warm outside, these lovable insects leave their hiding. But as the temperature drops before a rain shower, they fly in search of cover. Frogs can also predict rain. Right before the first droplet, these amphibians croak louder. They actually do this because they're about to mate. Frogs lay eggs in bodies of fresh water. If rain is coming, then water levels in ponds will rise. This increases the animal's chances of finding a partner to produce tadpoles. Have your parents told you to stay away from hornets' nests? They were right, but the nests of bees, wasps, and hornets make for excellent weather stations. When they start building nests higher than usual, expect a colder winter with a lot of snow. You see, hornets cannot survive temperatures lower than 50 degrees Fahrenheit. That's why they want to stay clear of the cold as much as possible. Another animal that bulks up for winter is the squirrel. Take notice of these cute rodents the next time you go hiking in the late fall. If they seem chubbier than usual, then the winter is gonna be cold. And remember Scrat from Ice Age? The hyperactive squirrel that was constantly chasing after an acorn? When you see a squirrel acting like Scrat, then that's a sure sign of a long winter approaching. The rodents want to stock up before Mother Nature closes the shop. Have you noticed more cobwebs in your house recently? That's just spiders sensing bad weather approaching. Also, if spiderwebs are larger than usual, then they're trying to catch more prey. That's their way of preparing for a long winter. Livestock prepares for this period by growing thicker fur. If you live in the countryside and notice that sheep are woollier than usual, then it's time to invest in a warm winter jacket. Are there mole hillocks in your backyard? Apart from tripping on them, you can use them as tiny weather stations. The deeper they are, the harsher the winter. Let all those animals rest a bit. Looking at the sky can also tell you the weather. Duh! There's a popular theory that every foggy day in August equals a day of snowfall in winter. Pretty exact math for something that's just a belief. Then there's the moon. Science already knows that it has power over ocean tides. After all, the saying, "Clear moon, frost soon," has been around for a while. When the moon is shining bright in a cloudless sky, it's gonna be chilly the next morning. Looking at clouds also gives hints about the weather. White clouds high in the sky indicate a clear and sunny day. When their color changes to black and they're set lower in the sky, expect rain. The cloud's shape is also revealing. If they're ragged when you look at them from below, open your umbrella. It's gonna rain soon. Remember the onions from the beginning? They're not the only plants that can forecast the weather. In the Ozark Mountains, there is a folklore belief that involves persimmons. When you cut in half the seed of this sweet fruit, look for the shape inside. When it resembles a spoon, expect snow that winter. But if you see a fork, then the cold season will be mild. A knife shape and the weather will be windy and icy. This strange prediction based on cutlery has some logic behind it. American persimmons ripen in September and October. It shouldn't be surprising that people use this fruit to inquire about the winter ahead. The United States is the world's second largest producer of apples. That makes it easy to test another theory. If apple trees produce more fruit than usual, then the upcoming winter will be harsh. There are two explanations why this might be true. The first is that apple trees produce more food for the animals. The second is that they want to maximize the number of seeds, just in case the plants don't get through the cold spell. Walnut trees use a similar tactic. People figured out that walnuts have a thicker outside shell in preparation for a winter colder than usual. The same goes for hickory trees and oaks. Pine cones are more than a table decoration. The phrase, "open pine, the weather's fine," says it all. Pine cones open their scales during warm and dry weather. They want to spread their seeds as far as possible. But when the weather takes a turn for the worst, they close them. Cold or damp air won't disperse pine cone seeds very far. Today, no one goes into the forest to see how plump squirrels are, nor do they take out a ruler to measure pine cones. All the info about the weather we need is inside our smartphones and on the internet. In the 1950s, computers took over weather forecasting, and they've been doing it ever since. But inaccurate weather predictions still happen. Long-term weather forecasts are especially challenging. That's because there are so many factors at play. Wind, humidity, temperature, air pressure, and clouds are just the tip of the meteorological iceberg. Although it's just a tradition, Italian onion reading might not be so ridiculous after all. At least the nice lady uses the onions to make soup after everything is said and done.
June 29th, 1764, seemed like a regular day in one small picturesque town in Germany, Waldeck. Residents were in church. Little did they know that a powerful storm was about to hit the area. It wasn't just an ordinary storm, it was a strong, swirling tornado getting closer and closer. It was an F2 tornado at the beginning, strong enough to uproot trees like oaks and beeches. But as time went by, it grew and became more powerful. It even picked up 2 children on its way and threw them into a lake. Something strange happened too. The water level in the lake rose and then quickly retreated. Leaving the lake behind, the tornado struck a house, tearing off the roof and knocking down the walls. Then the tornado changed direction and headed east-northeast, increasing its intensity to F3 level. That's when something fascinating happened. A possible twin or satellite waterspout merged with the tornado along the shore of Lake Luzin. It was like 2 tornadoes coming together. It got wider and stronger, so it started snapping and uprooting solitary oak trees, flinging them 115 feet into the air. It left behind a barren landscape, removing crops, grass, and even topsoil. Back then, people couldn't even read or write very well, let alone use devices that could predict a tornado. This one was so strong it destroyed houses, barns, and even uprooted trees. Such a terrifying thing to see. But there was something special about the church people were in. It had strong stone walls, so they were safe inside, even though everything outside was getting destroyed. They didn't even realize how lucky they were until later. With winds estimated to be over 300 mph, it was unstoppable. The tornado traveled a distance of 19 miles and stretched to a maximum width of 0.6 miles. A raging storm threw tree branches so high, people believed they ended up in the atmosphere. Another strange thing about this tornado was that it occurred during a dry storm. There was very little rain reported, but the storm still managed to make such a mess. It even produced large hailstones, some as big as 5.9 inches in diameter. Just imagine chunks of ice that large falling from the sky. These hailstones caused significant damage to crops and properties, and everything else that was outside at that time. After the storm passed, one scientist, Gottlob Burchard Gensmer, studied the damage and talked to people who had witnessed the tornado, only to realize this was one of the strongest tornadoes ever recorded in history. It reached F5, the highest rating on what's called the Fujita scale, which measures tornado strength. It took an hour for the madness to stop. Back in 1925, people in northeast Missouri didn't have an organized tornado warning system either. It took them by surprise when one day, in the early afternoon, they saw a tornado forming in that area. At first, it was a small one that briefly lifted off the ground. But as time went by, it started growing into a massive monster. Meanwhile, in West Frankfort, Illinois, some miners were working deep underground, about 500 feet below the surface. Suddenly, the power went out, and they knew something was wrong. They quickly started climbing up the shaft to get to the surface. When they finally made it, they were in for a terrible shock because of the devastating consequences of this giant tornado. The tornado didn't even stop there. It kept on making a mess as it traveled a long distance. It plowed through the land for a whopping 219 miles, all the way from near Redford, Missouri to the east of Princeton, Indiana. It moved at a crazy speed of 73 miles an hour. In one town, Murfreesboro, Illinois, the tornado wiped out a staggering 100 blocks of the town, plus another 70 blocks ended up destroyed by fire. In another town, Griffin, Indiana, not a single building was left standing. The tornado got weaker only at 4:30 in the afternoon. This tornado, known as the Tri-State Tornado, really made history as the worst and longest-lasting tornado ever recorded in the United States. In April 1965, people in the region of the Great Lakes started complaining about this weird heat. The forecast showed no storms for that area, It was because of thunderstorms sweeping across the upper Midwest of the United States. These storms were insane and so powerful they created 51 tornadoes in just 12 hours. The states of Indiana, Ohio, and Michigan ended up being hit particularly hard. Something unfortunate happened during this time. All this caught the forecast team, the National Severe Storms Forecast Center in Kansas City, Missouri, off guard. They quickly tried to send out warnings to let people know what was happening, but many people didn't hear the announcements because there were no outdoor tornado sirens at that time. Additionally, a lot of TV and radio stations didn't regularly broadcast weather alerts. Power was gone, and telephone lines didn't work, which meant many towns were completely cut off from communications. People couldn't receive the warnings because they didn't have access to electricity or working phones. One spring day in 1974 was especially hard because of severe thunderstorms that unleashed a series of powerful tornadoes across 13 states in the United States. These tornadoes lasted for 16 hours, and they ranged from weaker F0 to the most powerful and destructive F5 ones. At one terrifying moment, there were 15 tornadoes touching the ground at the same time. One lasted for more than 2 hours, and 2 others were swirling around each other like dancers. This was another big lesson, after which some changes in tornado warnings were made. In those days, weather forecasters could only warn people about a tornado if they had seen one with their own eyes, which was mostly too late. April 26, 1989, at around 6:30 in the afternoon, the sky above one district, Maniganj in Bangladesh, turned dark and ominous. The tornado began its journey from one point, Daulatpur, and moved swiftly eastward, Saturia, Maniganj Sadar. People living in that region had already been facing a severe drought, and little did they know there were even worse scenarios coming. The storm was fierce, stretching about 10 miles long and 1 mile wide. It covered a relatively small area, but it still caused enormous damage. It tore through the land and blew away buildings, thousands of trees, strong and rooted for years, and everything else in its path. The countryside of Marsala in western Sicily is really beautiful, but it wasn't so stunning on December 8th, 1851. 2 fierce tornadoes suddenly swept across the land, leaving nothing but chaos. As they moved, they brought along heavy rain and hailstorms, causing even more damage to the already vulnerable farmlands. One town, Castellammare, had an amazing harbor with plenty of ships, and it suffered great damage. The news of this devastating event reached far and wide, even making its way to the Illustrated London News. The outbreak in Oklahoma from 24 years ago, May 3rd, 1999, was tough too. Just one stormy day caused enormous damage from Texas all the way up to South Dakota. At least 45 tornadoes touched down, and Oklahoma was hit the hardest with an F5 tornado. The story seemed familiar. What first seemed like a small twister quickly grew into a massive force that, at one point, measured 1 mile in width. This one ripped asphalt from roads, peeling it away in layers like fragile paper. It tore the vegetation away and even wrapped roofing materials around power lines. NASA scientists studied the area using satellites. They realized it would take between 10 to 20 years for the vegetation to fully regrow in the region where the tornado left nothing but muddy, barren land. Oklahoma is in a pretty unfortunate spot when it comes to tornadoes. Take 1947 as an example. The Woodward tornado got named after the city it had struck. This monstrous tornado was massive. It reached 1.8 miles in width, and it raced forward at an incredible speed of around 50 mph. Before reaching Woodward, the tornado had already caused a lot of mess in other towns along its path. But it was in Woodward where it unleashed its worst fury. Without any warning, it struck the city at 8:42 in the evening, catching the residents by surprise. Communication with the outside world was cut off, leaving families uncertain about the fate of their loved ones. As if one tornado isn't enough, some areas get struck by a series of them. In 1908, an outbreak of tornadoes swept across the eastern part of the United States, from Texas to Georgia and then northward from Oklahoma to Tennessee. At least 34 tornadoes touched down. Nature showed no mercy. Buildings were torn apart, and once thriving streets were reduced to rubble. The Fujita scale measures tornado strength based on 2 things: The speed of the winds and the amount of destruction caused. F5 tornadoes are the strongest, most destructive ones. I mean, some people talk about F6 tornado with winds that could blow at over 300 miles per hour. If this one was passing by, you'd definitely know how Dorothy felt. Luckily, F6 exists only in stories, and Oz is the last place you are likely to end up at.